All right, we are starting my very favorite chapter, the chapter on rules of exponents, chapter 7. 7.1 is about 0 and negative exponents. If a is a non-zero number, then a to the 0 equals 1. So in other words, whatever it is, if it's not 0, if you raise it to the 0 power, it's 1. So 8 to the 0, just a 1. 27 to the 0, just a 1. 12 to the 0 x to the third, this part is the part that's to the 0, so that would be 1, but I still have this x to the third, so it would be 1x to the third, or just x to the third. Negative 4, n to the 0. Again, this is the only thing that's raised to the 0 is that n, so my negative 4 stays the same, and then it's times 1, which is just negative 4. 6x over 6 to the 0. Well, again, exponents before division, so I do the exponents first, so 6x. 6 to the 0 reduces to be 1, so that is just 6x. And it is that simple. Let's see, explore an exponent. So 2 to the x, that means if we put in any 2, what do you suppose is back here? Oh, rules, I think. All right, so 2 to the 4th, you all know how to type that into your calculator. 2 to the 4th is 16, which is 2 times 2 times 2 times 2. 2 to the 3rd, which is 2 times 2 times 2, is 8. 2 to the 2nd, 2 times 2, which is 4. 2 to the 1st is just 1, 2, so it's just 2. 2 to the 0, again, anything raised to the 0 power is a 1. Here's where it gets interesting. 2 to the negative 1. So if you, on your calculator, plug in 2 to the negative 1, it's going to tell you 0.5, or 1 over 2, 1/2. If I type in 2 to the negative 2, it's going to tell you 1/4, or 0.25, which is 1/4. So now let's look at 10 to the x. So 10 to the 4th is 10,000. 10 to the 3rd is 3 zeros. 1,000. 10 to the 2nd is 100. 10 to the 1st, I should maybe have written these in there, is just 10. So let me go back and write those in because you probably don't know what it is. So 10 to the 4th is 4 zeros. 10 to the 3rd is a 1 and 3 zeros. 10 to the 2nd, 10 times 10 is 100. That's a 0. 10 to the 1st is 10. 10 to the 0, again, anything raised to 0 is 1. 10 to the negative 1, it's going to tell you is 1/10. 10 to the negative 2 is 10 to the negative 2 is 1/100th. So hopefully you'll see a pattern. Here's 10 to the 2nd, here's 10 to the negative 2nd. Here's 10 to the 1st, 10 to the negative 1st. Same thing happened with the 2's, and I'm hoping you'll see it. So negative exponents for every non-zero number a, and integers n. So it's just saying this works for anything. If you have a number or a variable raised to a negative n, then we, again, you know how we do flip it and switch it? This is another flip it and switch it. So this was over 1, we could have written it. So now I'm going to flip it. It was in the numerator, and now it has to go to the denominator. And the exponent was negative n, and we switch it to n. Or we can say move it and lose it. So we're going to move it. So right here, this example, 2 is in the numerator. So I am going to put it in the denominator. And then lose the negative. So instead of to the 4th, the negative 4th is 2 to the 4th. And if we need to simplify that, that would be 1. And I can just look at the 2 to the 4th one over 16. All right, so here's my general rules up on the top. And now we're going to do some problems. So negative 5 to the 0. Is it something to the 0? Yep, it's a 1. 7 to the 0 times 2 to the 3rd. Well, 7 to the 0 is 1. So times 2 to the 3rd. 2, so it's 2 times 2 times 2 is 8. 12 to the third, x to the 0. X to the 0 is 1, so I'd have 12 to the third times 1, which is just 12 to the third. And if you plug in 12 to the third, you get 1728, so 1,728. All right, 4 to the negative fifth. Here's where we have to do, we have to move it and lose it. So I know that I'm going to move it to the denominator. It wasn't the numerator. And in my calculator, all I have to type in actually is 4 to the fifth, right? That's a lot neater than typing in the fraction. So it's going to be 1 over 4 to the fifth, and 4 to the fifth is 1,024. So 1 over 1,024. Let's see, 12x to the negative 2 over 6 to the 0. 6 to the 0 reduces to be 1. 12x to the negative 2. Remember, this is 12 not raised to an exponent, so that's just going to be 12. And this x to the negative 2 right here, I have to move it and lose the negative. So I moved it and lost the negative. This one, 4 to the negative 8th, move it, lose the negative. And 4 to the 8th is 65,536. 65,536. All right, so let's look at this negative 4 and to the 0. Again, negative 4 isn't raised to the 0, so that's just negative 4. N to the 0 cancels out, makes into a 1, so the answer is just negative 4 there. Let's see, this reduces to be 1, so I don't have to worry about that, right? This is just 1. But this 3 to the negative third, I have to move it and lose the negative. And then x, I don't do anything to change, so it just stays on the top. So 1x over 3 to the third reduces to be x over 27. Negative 4 to the negative 2, again, it's raised to a negative exponent, so I move it, and I lose the negative. And negative 4 raised to the second is negative 4 times negative 4, so it's 16. So the answer to that is 1 over 16. So simplify the following. These are yours, so you should pause me and then come back and check your answer. So put me on pause, come back and check your answer. So here's the answers that you should have gotten. I just want to take a second to talk about this one here that's circled. And if no matter where the negative exponent is, you have to move it and lose it. So in this case, it was in the denominator, so it moves to the numerator and becomes x to the fifth. So hopefully you got those done. Now let's look at evaluating an expression. So that means when we're going to plug something in for it. So there's two ways we can simplify first, which is the way I like. So this is what I like. If we have 3s to the third, t to the negative second, if I want to rewrite that simplified, it would be 3s to the third over t to the second. And now I can plug those numbers in. So I have 3 times 2 to the third, because it says s is 2, over t, which is negative 3. And remember your parentheses, negative 3 to the second. So that equals, it's 3 times 2 to the third. 2 to the third is 8. So 3 times 8, which is 24, over negative 3 squared, which is negative 3 times negative 3. So that'd be 9. Those are both divisible by 3. So the answer would be 8/3. Here's the other way to do it. You substitute the numbers in first. So I have 3, 2 to the third, negative 3 to the negative second. So then I would simplify it. I have 3 I could do this 2 to the, well, actually, I'll put a parenthesis, 2 to the third, 2 times 2 times 2, 8. But I have to move this one and lose the negative. So that would be 3 times 8, which is 24, over negative 3 times negative 3, which is 9, which again is going to reduce to be 8/3. All right, so let's take a look at these. And here, I think in one of these, you'll see why I like to do the simplifying first. So I'm going to simplify first because that's how I like it. Because w to the 0 reduces to be 1, so it's gone. But n to the negative 4th, I have to move it and lose the negative sign. So that would be 1 over negative 2 to the 4th, which is 1 over negative 2 times negative 2 times negative 2 times negative 2. So it's going to be positive 16, but you can plug that part into your calculator, the denominator. This one to simplify, I'm going to put n has to be on the bottom to the first, w to the second, and there's just going to be a 1 on top. You can't have a 0, it's just 1. So I have 1 over n to the first, which is just n. So n is negative 2, and then w, which is 5 squared. So equals 1 over negative 2 times 25, which is 1 over negative 50. So that is my answer for that one. C. Remember, anything raised to the 0 is just 1. So I have over w to the 6th. So this would be 1 over 5 to the 6th. And 5 to the 6th is 15,625. 15,625. Here, this one needs to move and lose, so it'd be w to the first over n, I believe, but I wrote too big on it, so let me see. Over n, w to the first, just 5 over n, which is negative 2, and I can't really do anything to simplify that, so it's 5 over negative 2. All right, so here's an example of where you use it in science. Population growth. A population of marine bacteria doubles every hour under controlled laboratory conditions. So the number of bacteria that you have is modeled by the expression 1,000 times 2 to the h, where h is the number of hours after a scientist measures the population size. So it says evaluate it for h is 0 and h is negative 3, and then what do those mean? So let's look. Let's evaluate times 2 to the 0. Well, remember, that would be 1,000 times 2 to the 0, which is 1. So that's just 1,000 bacteria. And the other one was evaluated at time of negative 3. So that would be 1,000 over 2 to the 3rd, which is 1,000 over 8. Which reduces to be 125 bacteria. And it says, kind of talk about what do those things mean. Well, t of 0, t to the 0, is at time 0. So when he just starts or she just starts this experiment, how many bacteria are in the jar or the petri dish or whatever, and it's 1,000. But then it says evaluate at t to the minus 3. That's 3 hours before we started the experiment. So if we were to look back 3 hours before the experiment started, we'd have 125 bacteria. Now, I don't know if that's possible because I don't know if they were in a container before that, but that is what that would mean. All right, that's it for this section. It'll take me a second to turn it off.